What would you see with a chart like this? You might say B, or some might say 13. But neither is certain. What if it were this picture? We would be pretty sure that it was B, because this time we see the world with some more information, A and C. This information prompts our brain to think it is B. If we then change the diagram to this one, this time we would change our mind and say it is 13. Finally, looking at the diagram again, we would say that this answer could be B or it could be 13. But for people who don't know letters or numbers, they will never be able to read this chart, so what we can see is not determined by the objective world in front of us. Rather, it is determined by the knowledge and experience stored in our minds. The question arises: is the universe we see the real one? In 1982, an amazing thing happened in the physics laboratory of the University of Paris. Scientists discovered that, under certain circumstances, if we send elementary particles, such as electrons, in opposite directions at the same time, no matter how far apart they are, when the direction of motion of one electron is disturbed and changes, the direction of the other electron changes at the same time. There always seems to be some kind of communication link between them, and this communication is almost timeless. And this violates Einstein's theory of relativity. No communication speed can exceed the speed of light, because once the speed of light is exceeded, it means that the boundary of time is broken. Faced with this appalling physical phenomenon, quantum physicist David Joseph Bohm put forward a very bold and simple hypothesis that objective reality does not exist. And that although the universe appears to be concrete and solid, but it is actually just an illusion. A huge and detail-filled two-dimensional holographic photograph. And the universe we perceive is a three-dimensional projection of this holographic photograph. This is the famous holographic universe theory. Bohm believed that the reason for this FTL connection between elementary particles is that everything is connected, and all elementary particles are not separate independent parts, but a small fragment of a larger whole. It is as if a shark swims, and when we look at this shark through two small holes without hinting, we will decide that these appear to be two different fish. When one shark turns, the other moves accordingly. So we would conclude that there is some sort of instantaneous communication link going on between these two sharks. But this is not the case. These two sharks are just two aspects of one shark. So, even though humans have been trying to classify the phenomena in the universe, the fact is that all classification is an illusion, and everything in the universe is as indivisible as different pictures on a carpet. In fact, the theory of storing information from three dimensions in a two-dimensional plane began with the knowledge of black holes. Scientists found a contradiction between relativity, which describes macroscopic objects, and quantum mechanics, which describes microscopic particles, in explaining black holes. In the early days, scientists believed that when any object was swallowed by a black hole, the information it contained would disappear with it. However, quantum mechanics requires so-called unitarity, which means that the information in the universe does not disappear, but only transforms. In 2016, Stephen Hawking made a hypothesis in a paper that the information of matter swallowed by a black hole is not destroyed, but remains forever on the two-dimensional plane of the event horizon of the black hole. That is, the information of the three-dimensional world is printed on the two-dimensional plane of the visual interface. The holographic universe theory suggests that before the universe was born, all information was stored on a two-dimensional disk. As information increased, the two-dimensional disk could not carry this information, so the disk eventually transformed into a three-dimensional sphere, and the information from the sphere was projected onto the inside of the sphere, forming forms of matter such as energy, until the birth of the universe as we know it now. Like the black hole visual interface, information from what we see now, including every atom on every star, to every star in tens of billions of galaxies, is all stored on this sphere. This giant bubble surrounding the universe is like a cosmic hard drive that holds the source code for all the information on it. In 2017, a team of researchers from the University of Southampton in the UK announced for the first time the observation of direct evidence of a new theory of the universe. We know that the cosmic microwave background radiation is the thermal radiation left behind at the beginning of the universe, and by studying the microwave background radiation we can learn key information about the birth of the universe. The research team has simulated the microwave background radiation distribution of the holographic theory model of the birth of the universe by supercomputer, and the pattern fits well with the microwave radiation distribution of the known universe mapped by Planck's satellite, thus strongly supporting the holographic theory of the universe. Since the universe is a three-dimensional projection of a hologram, so would it be like the holograms in science fiction movies that also have occasional glitches? Therefore, scanning the holographic universe for faults has become one of the important ways for scientists to verify the holographic theory. In holographic theory, space-time is not smooth and continuous as Einstein described, but broken down into particles. During holographic projection, the two-dimensional sheets move one after another, thus causing synchronous vibrations in spacetime, which in turn can produce tiny glitches in three-dimensional reality. At Fermilab, physicist Craig is using holography to detect such extremely small spacetime vibrations. In fact, holographic theory can also explain one of the biggest mysteries of the universe, dark matter. In the last century, physicists discovered that the observed mass of matter in the universe is simply not enough to sustain the current speed of celestial bodies, so scientists hypothesized a mass called dark matter to provide additional gravity. Even though physicists have spent enormous human and material resources to search for dark matter, nothing has come to fruition until now. Holographic theory suggests that we cannot find dark matter because dark matter itself does not exist, and that the irrational state of galaxies is a natural feature of a whole new universe. Dark matter is just an illusion in the holographic projection, the two-dimensional plane that stores information about the universe, fixing and providing the entity of the three-dimensional universe. Some people say that the holographic theory is so illusory and ethereal that it is pushing scientists step by step to a precipice of thinking. Scientists seem to be trying hard to prove that they are virtual and make us believe that everything boils down to nothing. So is there really no little real information in the universe? The answer is no. Information does exist in the universe, whether it reflects the deep structure behind the universe or this phantom universe itself. And it is necessary to describe the entire universe. A grain of sand may not be able to contain the entire universe, but a flat panel display has the potential to do so. So, from an information point of view, our universe has unfortunately been reduced to a hologram. The great ancient Roman philosopher Saint Augustine famously said that miracles do not occur in violation of the laws of nature, but only in violation of nature as we currently know it. Perhaps he explained the holographic universe theory very well.